All right. Hello, everyone. This is our wonderful team 42, consisting of Lukas, Nick, Gabi, Sarah, and me, Leonard. And we also were in seminar room 42, so that was perfectly fitting. And you're going to see smileys on all our slides. That's very important. And with that, I would like to get started with what we actually did, or like our approach. Actually, kind of boring because we just changed the XGBoost hyperparameters to actually good values. We had some ninja in our group who really knows very good values. And we tested something else that is actually a really cool idea, automatically stopping random forest from Felix Moore. You might know it from, I don't know, Twitter or the AutoML conference where he presented something similar. Sadly, this didn't work for multi-level classification and multi-output regression yet, so it crashed. And in general, we were not able to get it run properly in the end. Nevertheless, on the one data set where it worked, it was the best method. So that's cool. And the idea of this is that you don't have to specify the number of estimators for your random forest, but you just run your random forest and it automatically takes, like it stops at some point building random forests, or like building additional trees, which is really useful. All right, with that said, our approach was very basic. Now let's talk about the important part, the hyperparameters. And this is the configuration which we have used. The two really important parts are actually just the number of estimators to be really high, and the early start point to be around 20 or like even higher sometimes. And with these hyperparameters, we spend a lot of time getting it to run, or getting it in general to run. And with that, we can take a quick look at the results. First of all, the results for validation. Be aware everything here is log scaled. So we can see here for the Nyaprano validation loss, we can see a constant increase in performance. Lower is always better. Here it took some time. Over here at Val it took some time. And here it's almost similar, but actually, like absolutely speaking, we are better in all of these cases. We're only showing you 4 data sets because we were only able to get it to run for these 4 data sets on our machines and in the notebook. The other point is obviously the test results, only 3 of them, which we sadly have, the rest crashed, which looks like this. So we actually improved with our, not randomly, but expertly picked hyperparameter configuration on all of these versions, or on all of these data sets. And we also took the time to submit this to the official thing. However, we had to do 3 submissions because we realized bugs in our submissions, and hopefully the last submission now runs on all data sets, but we will see in a few hours. And with that said, this was our secret ingredient, as always, random seed 42. And one last thing, we just want to give you a conclusion, what we actually did the main time, right? We spent a lot of time discussing the code, smiling, trying to make it run, and a little bit of tuning XGBoost. And otherwise, we would have really liked to look at how we can ensemble different modalities, but we didn't really get into that part yet. Thank you very much. Any questions?
One question, did you use the same hyperparameter setting for all of them?
Yes, but that's the reason that's not the reason it's crashed, but one of these, the continuous data sets are framed as a multi-output regression task with like hundreds of outputs. And if you do XGBoost on this will produce an immense number of trees, which always runs into memory errors. So that's where we plugged in random forest instead.
Right, so regression is multi-output.
No,
there are some tasks are defined as continuous tasks, and those run with multi-label regression, and that's basically a memory hog for XGBoost, and so we weren't really able to run it. It runs on the on Colab, but it takes forever, and so even if we would have let it run for all this time, we would have probably not even gotten a result. So we just decided to stop. We eventually subsampled it, and even with 1% of the data, it took forever. So we just figured it wasn't really worth it. We just figured out which data sets would actually be able to be evaluated, and so we showed those to you.
Great, and thank you. Any questions from the organizers, comments? Otherwise, we go to the next team.
Awesome. Thanks for the presentation.
Thank you.
Thank you again. Next team. There was one back there. Oh, no, there was one here. And there was one back there. You don't want to present anymore? Depending on what they say.
Yeah, so get A, B, C, because I didn't put the names.
Okay, whatever.
So, are you in the Zoom call already?
No.
Are you in the Slack channel?
No.
Can we get
Can I
through
add
this?
you?
That might take a little
Yeah,
while.
but
Can we connect?
there's another.
Would you be ready?
I think I have done
Would Hannover be ready for a talk? Is any of you on Slack? Who's that?
Slack.
Do you have a laptop?
Allow us to share our screens.
Defan, did you say someone is ready?
No, we said that can you allow us to share our screens? You already said.
Oh, yes, yes.
And who should?
Defan, I think.
Decathlon or the?
Defan or AutoML, Hannover?
AutoML Hannover.
The room.
Okay,
Right.
now it should be fine.
Wait, then you have a little bit of time.
Yeah.
I don't know. I've not understood what you're saying. You said you gave forward to someone.
Or can we?
Defan, is this working?
So don't know that the host will disable the participant screen sharing.
Defan, that's your account, right?
Oh.
So your account Defan is
Yeah, you need to give you.
so not that one, but Defan is the permissions.
Yeah.
So
Get Defan, please. Make Defan's account and co-host. Wait a second. Okay, Defan should be able now to share the screen. Perfect.
So, can you hear me all right?
Yep, perfect.
Okay, so, well, the task is, of course, the auto selection of ML systems for very diverse tasks. And our first idea was perhaps never going to work for this hackathon. It was to use the metadata of the data sets and then basically meta-learn compared to other tasks sampled from OpenML to figure out what kind of task it approximately is, and then do something based on that. But obviously, it's a little bit complicated, especially on this short time frame, and would also have issues on some weirdly looking data sets.
Yes, and maybe in addition to that, we have also observed that even if you have like a certain class of data, like image data, even there is still a large variety of like a large variety in the meta features. So that would probably not be the best way to solve this task. So we discarded that approach basically.
Then our next best idea was based on the talks that we've seen so far in this course, that we just use AutoGluon to do everything, which sadly also didn't work. We might look back into this because it had some dependency issues on the notebook we used, but for now we didn't get this to work either. And then, well, we'll do it ourselves, we said. So this is our current approach to differentiating the different tasks and assigning them systems to solve. So first we would see, is it a time series? And if it is, then we plan to use AutoKeras forecasting. If not, is it an image? If yes, AutoKeras classification or regression. And if it is neither a time series nor image classification, then we're going to go back to good old XGBoost. And in order to solve the problem of some weird data sets, which we already observed in the data we've seen, if something in the dimensionality doesn't work, we'll just flatten it. However, we don't yet have any data to show for it. And well, look forward to the end of the actual Decathlon.
Maybe in addition to that, also there was some kind of data set. I think it was some kind of genome data set or so, which would be in a format of or in the typical format of an image, but it is obviously not an image. So that approach where we apply, I think we applied the flatten approach there. Yes, the flatten approach might not work there. It could potentially work, but we are not sure about it. It could be a problem. But all other data sets are not in such a format. So, yes.
That's our current approach. Thank you for listening.
So does anyone have some questions for us? Or is everything clearly understandable?
Yeah, thanks.
All
for
right,
the
do you hear me?
Oh,
Right.
sorry. Go ahead.
All right, you go.
No, I was just gonna say, like, thanks for the presentation. This is it's cool that you tried all of these things, and like I like this this plan that you have for trying this like if-else branching thing. I can say that based on the baselines that we've like released in the code base, that these like if-else things tend to work quite well. So definitely recommend trying to implement this. But very cool. Thanks again.
Quick question from here about so there's one data set they said that looks like an image data set but is not an image data set. Can you say more about that? Maybe also from the organizer side?
I think it was.
Does this happen?
It was basically nested lists. So if you look at the dimensionality, it's similar to how image data is obviously two-dimensional. We can differentiate it, but the issue is more with will normal tabular data machine learning work well on a data set where the dependency between the features is very important. That was our question in that regard.
Okay,
Sorry,
so not really a question to the organizers, or is it?
Oh, sorry. Yeah, which data set was this that you're asking about?
It was I think it was a genome one.
It had the format, I think 1.4 1004 or something like that.
I see. Yeah, that sounds like it's probably like genome data. So yeah, I mean, it makes sense that it would be like a sequence by 4 because there are like 4 like base pairs, right? But yeah, I mean, like for things like this, people do things like 1D convolutions and stuff like that. So you can, in some sense, like treat it as like having some kind of like 1D like spatial dependency. But that's like a design decision. I can't say much more than that. But yeah.
All right, cool. Thank you. Any other questions? Rhea, you ready? Okay, then we'll have the next team from here. Thank you. Thanks again, Hannover. And was this a one talk from Hannover, or are there more?
Probably that will be only one presentation from our side.
Okay, good, thank you.
What's your name? Okay.
Okay, so we will present 2 ideas that we were analyzing. But at the end, we couldn't test it if it works. So the first idea is based on ensembles because I noticed that they are quite used in AutoML system. And also I have seen in some other papers that ensembles, meta-learning techniques, normally they have very good results. So basically, when we work with the ensembles, it's important to ensure that there is a diversity in the models that you are incorporating in this ensemble. And there are 3 ways to add this diversity. One is using different subset of intents. That is basically what Baggins does. Also, you can use a different subset of features or using different machine learning models. So basically, what I was trying to do is to combine these 3 things. So we started with a data set and then randomly select some features. You can define how many times you will do this. And then for each of these sub data set, I will select some instance, and then I will train the model with this sub data set. And at the end, I will use some fusion mechanisms to combine all the output of these models to produce a final output. And in this case, we can use the average or a majority vote or other techniques. But in this case, it's using the same model. So if you use support vector machine, is support vector machine training with all these sub data sets. But of course, we can use different machine learning models. But because we know that we can use some AutoML system to select these models, then of course we can use a layer and say, for instance, use AutoScaler to given a data set, select either a subset of machine learning models and their alpha parameters, optimize it, and then combine all these models into a big ensemble. So basically this was the idea. I started implementing this part, but then I had some issues with Colab, and so basically I only tested 3 models, so, and after that I run out of RAM, and then I couldn't do anything else. So
yeah, and then yeah, for this other idea, we were wondering, okay, so we can maybe use the metadata and try to pick a problem-specific model or set of models. But what would we do if we can't really do that based on the metadata? And so what would be just a kind of standard go-to base model to try? And so we decided to, similar to the previous scoop, to try flattening everything into a table and setting it to AutoGluon. We were able to get AutoGluon working, but an issue that we ran into, I mean, one is that there's a lot of information that's lost once you flatten everything into a table. And also, currently, AutoGluon only supports multi-label outputs through essentially training a different model for each output. So this really doesn't scale well once you have more than a couple of outputs, and also memory became a bit of an issue. So we got it up and running, but didn't really have time to test it. That's that. I'll take your question.
All right, any questions? All right, we'll go with the thank you.
Change the Zoom.
Melina soll es sein. Soll ich den auch machen? Du kannst auch, ich weiß nicht. Dann machst du da, okay? Und ich mach das hier am Platzen. Und so hier. Oh mein Gott. Okay, let me try. Okay, so hi everyone. My name is Melina, and Larissa and Linian. And we started as a group of 7, but now we went to 3 people. We also tried like different approach, but unfortunately we weren't able to run any, so we now want to present you our idea. So, I mean, you've all seen the task. We have as input, data, metric, and the task type. Then we basically have the data in a standardized form. And we have this magic box in the middle with a time budget constraint, and we want to output a machine learning algorithm or model. And our task is to basically design this magic box and also beat the baseline that's given. We first thought about like how do we want to design our magic box. So we first thought we should exploit the metadata we have from the data sets. So we first thought to get based on the data size and the size of the data set, we want to extract the data domain, and given the data domain, the metric and the task type, we want to decide on a framework and its optimization target, and then run this one and get like the best machine learning algorithm and model out of this one. So the first step you saw was to infer the data domain, and we want to do this based on the standardized data format. So the first decision we make is it's T1, then we know there's no time dependency. And if it's larger than 1, then we know that there's a time dependency. And as soon as H and W, so the height and the width, are both larger than 1, then we might infer that this is a video. And based on this decision tree, it's the case for the Navier-Stokes dataset. And if they're both equal to 1, then we infer that it's a time series, which would be the case for the Crypto and the Nottingham dataset. And then lastly, if the time is equal to 1, then we can either infer that it's tabular or image data set, which is the case for the other 4 data sets.
Yeah, so then now that we have the metadata, we can choose a different search space, and we decided to use AutoSKLearn for tabular data, AutoGluon for time series data, AutoPytorch and AutoKeras for image and video data. Of course, for continuous tasks, we use a regression, and for multi or single label task type, we use a classification. And yeah, and then given the metric, the model will be evaluated. Yeah, good, right. Yeah, what we actually did, we inspected the data sets, looked at them a bit, were confused a bit by some of them, for example, that deep sea that another group mentioned. And then we decided to first apply to one of the data sets, which was the easiest one, the images, to apply a few algorithms and see what works. And well, we tested AutoGluon, AutoCV, and AutoPytorch. AutoGluon actually ran. The results were not that good, though. I don't know if that was our mistake or if, I don't know. Yeah, maybe we configured something that didn't work, but we didn't have time, unfortunately, to look into it further. But the idea would have been to do this for every data set, and we see which framework is actually the best, and then use that for those types of tasks. Right, and the summary, we need to reach 3 goals for our approach. We need to infer the data domain. I think that worked hopefully pretty well. Then we needed to decide on a framework for each of the different task types and find the best algorithm and model with AutoML and HPO. Yeah.
Okay. Any questions?
For the presentation, very good, very good, very cool. So yeah, I guess. Sorry.
There's a question.
Okay.
No, so we were only able to run AutoGluon and this AutoCV. AutoCV was actually an approach that one of the winners of the AutoDL challenge chose. And also like the whole idea on this in-field data domain is also based on their approach. But we were only able to run these tools, but they didn't we didn't get to any great results that were actually really better than the baseline.
Was the formatting of the data similar to the AutoDL?
It was like the whole setup was pretty similar, but they kind of changed a little bit the data loading part. So that had to be changed.
So are you saying that actually use baseline was better on this image task that basically these almost right?
Yeah, but I think that's our fault because we weren't able to configure them correctly. Like, yeah.
Good. And thank you again. Is there any other team? Yes, there's a team now that has internet. Excellent. That was the issue. They couldn't connect to Zoom, but now they can.
Share the screen and do the magic.
I do the magic. No.
Okay, just close and open. Permission issues. We need 2 minutes.
Sorry.
Excuse me?
Yeah, because I didn't.
No, it's fine. It's
I just need to quit it and open it again. In my company, we're not allowed to use Zoom, so I never. No, my company is not terrible.
We are almost there.
Oh, now I have to go to the Zoom link again, right?
Yes, I sent it in Telegram. Maybe just search the Zoom. Okay.
Here
Yes,
it is,
yes,
right?
yes. So can we share this? No, we cannot share the screen. So just
It's this one.
Nadine. Catherine. Okay. So cool. Hello. So, well, I've been told to show this video as working, so I guess it's part of the Decathlon. And
Proof that you were.
yes, so basically, we just wanted to gather and solve this hackathon by what we learned here. So the idea is basically here how we have to pick an algorithm and how to tune the parameters to make a task, actually to solve a task. And we had very good talks and different architectures. And then we were puzzled what to use, because why do we have all these auto things? And what we tried, well, the first thing is this black box optimization. We were trying to do some random search and these kind of things. And then the other is like we were very excited for AutoGluon, and we decided also to try and make that one work, and auto scikit-learn. So what happened? This took too long to implement it, so we couldn't really fix the code. AutoGluon was just failing again, and auto scikit-learn, we could kind of make it work locally, but then we needed too many different Python versions and all these things. We submitted and it crashed online. And well, what we proposed, but of course this takes more time. What we were expecting usually when we solve a data science task is this nice comma-separated value files, and then we just give that as an input to whatever AutoML framework we have, and voila, we have the task solved. But actually, we got completely something else, and it was this PyTorch data set, some NumPy arrays, we couldn't see the data, and maybe now what I wanted to do is actually to do a bit of feature wrangling, feature engineering, because we actually know that thing that it's missing in most of the AutoML frameworks, or it's just like partially implemented in AutoGluon at least. So I said like, okay, that's the thing that we are going to win this hackathon, but then yes, it was completely this other type of data sets that we saw. So there are two things that we kind of have to, I guess, in the AutoML and auto data science community, we have to work more on, is this data wrangling, because apparently data are coming in too many different shapes, and whatever is that list of possible data sets, shapes that we can get, we have to learn automatically a program that is going to output in something that we can work with and understand. And then the other thing is that in the same approach, we have to do this feature wrangling. For example, here is this table, how I imagine this thing to work. So if we have one attribute name, we want also to get the gender there. So if you think about the Titanic data set, this hello world of data science, machine learning, this makes very much sense, because then what we are doing actually here, we are just moving the optimizer out of the learning algorithm and moving it to the feature wrangling part. And this is going to very much help and speed up the whole AutoML frameworks. And the idea then after that would be, maybe since we have too many AutoML frameworks, to kind of make an AutoGluon-like framework. So why not? So basically here we are just going to put H2O, auto scikit-learn, AutoGluon, all of this thing, make a stack, make this thing to coexist in the same environment. And then we have all this data wrangling and feature wrangling as an input. They go through this thing, they pick which one fits the best. And then in the end, we get the output for this one. On the right side, this is from the presentation of Nick. Like we have this concat and waitening, and we had no idea how we would do this with these things, but I guess that's the part where we should focus and work on this thing. And then whoever comes with new auto scikit-learn, auto vec, and this kind of things, we just pile them up in this framework here. And thank you. It was very nice to be part of this Decathlon. And
Yes.
I think it was really nice that you brought up the issue of data processing, because I think we had a lot of part too, and in the future we could save a lot of pain and time for the participating teams by doing basically what we propose.
Yeah.
Just additional confirming that what you said is
Thank you.
Yes. As the last comment, there's Ensemble Squared, which does what you described in like these ensemble different AutoML tools.
Okay,
But
well,
your
that's.
idea is still new because they didn't stack it.
Well, I guess stacking is the key, yeah.
Good. I think that was the final thing, right? Thank you again.
Thank you.
And maybe what could be super valuable to the organizers is any type of feedback that people might have that you haven't given in the presentation. So anything to add in terms of feedback? Was it easy to get started? Could there be things that could be made easier for you? Is this a natural format for different data sets? Yeah. Maybe people come to the mic because otherwise they won't hear, and they're really the ones who need to would be profiting from this information most. And others, if you want to say something, please come up. Don't be shy.
Hi. I think it would be better if it would be easier to run this locally and not restrict it too much to the collab. I mean, I don't know how the other teams felt about this, but yeah, I'm getting some thumbs up. But basically the first thing that we did was we copied the code into our local environment and set it up there. And that had a number of issues, unfortunately. And so eventually we went back to Colab, and that has also issues. And so we didn't really, like, we spent a lot of time working on stuff that, well, wasn't really necessary, I think. So I think next time it would be better if if there was more support for running this locally, in addition to Colab, of course, because I guess the GPU support is really nice, but for debugging, it's just a pain, basically. Right?
Yeah, I understand. Thank you for the feedback. I appreciate that. Also, one comment about this. For the purposes of the competition, we do have a Docker file that you can download that should have everything you need. But for the purposes of the hackathon, yeah, thank you.
Yeah, so we actually downloaded this Docker file, but maybe this sounds a little bit weird, but it was 4 gigabytes, and that was took quite a while from this network. So yeah, but that's a minor complaint, I guess. But it would be nice if we could actually run this even without Docker, maybe. That's not my personal preference, but yeah.
Got it. Cool. Thank you.
Defan said there is some people from Hannover.
Yes. So can you hear us?
Yes.
Okay. If I remember correctly, you said something that you are aware of some problems with AutoGluon with the whole competition data set, basically. I think you've said something during your presentation about that. Was that some problem? Was it, or are you also aware that there are some kind of AutoGluon problems with the hackathon data set here? Because we have tried to install it, and we had the problem that on its own, AutoGluon runs fine, but if we combine it with the given files here at the hackathon, all the installation and dependencies, then we suddenly get some weird errors about, I think it was about CUDA or something like that, which basically made it impossible for us to use AutoGluon. So
I see. Yeah. So as of, I would say, a couple days ago, we became aware of like a version mismatch issue with some dependency that AutoGluon requires, and we're working on releasing a patch to fix that. So hopefully we'll have something like that out soon. But yeah, unfortunately, there wasn't enough time before the hackathon for us to fix this. So I apologize for that.
Since we intend to like also submit something to the final competition, is it reasonable to assume that that AutoGluon problem for the competition will be fixed like in a couple of weeks, so that we can actually use AutoGluon? Otherwise, we would basically discard that idea and would go on with AutoKeras or something like that.
Yeah, I would say like we're gonna give it our best shot with this, but I mean, we're having to like make a bunch of different like dependencies like kind of work simultaneously. So I would say there's like no guarantees that we'll get it to work like fast, but we're gonna give it a shot. So I would say like if you have like backup options, I would perhaps like prioritize those. But there is a possibility that we'll have this up and running. Yes.
Okay. Yes.
Yeah, maybe one more question regarding that. So we submitted to the official thing. We didn't see a possibility to change the dependencies. So there's no setup file, or like I cannot put a Docker file. So how am I supposed to change the dependencies of the Docker container that is run in the official pipeline?
I see. Yeah. So so there are kind of two things. So one, we're kind of constrained to some degree by like the format of the platform that we're using. But the way that we've been recommending for people to install dependencies is to essentially like run like the installation from within your code, like before your script runs. So it's kind of hacky, but it does work and people have done it.
Yeah, okay. Yeah. All right, thanks.
Yep.
Any more comments?
All right. Then, yeah, I think that's it for comments from here. I don't know how you want to proceed. You had this, sorry, Sam. How did you want to proceed here? So there were presentations, you were going to choose a winner or something, or is that offline?
Sorry. Oh, sorry, I couldn't tell if you were talking to me or.
Sorry, in your presentation yesterday,
yeah.
you said something about
right.
Yeah, winners will get prizes. I don't know how you select winners. If this is now or offline or.
Yeah. So okay. Yeah. So I do have like some like a very short like slideshow for like some closing remarks. I think we're gonna take 5 minutes. Me and Junhong here is also an organizer. She's in the Zoom call. And so we're gonna take 5 minutes to discuss, and then I'll pop back in, and then we'll announce the winners.
All right, thank you.
Cool. See you in 5 minutes.
And we'll, all right, see you in 5. Just sort of a bathroom break. Way running around later on, so I thought this is a good opportunity where everyone is here. So she's responsible for us having coffee and food and everything and registrations, and thank you very much.
Thanks. We're awesome participants, thank you.
And I also had, we had wine bottles for the presenters. I had her get extra wines for her. She didn't know it for her.
She kind of wasn't fun. Thank you. Oh. Okay.
All right, you can notice.
I'm gonna get some coffee.
All right, good. 5 minutes kill.
Who is there?
Are we muted? Or? So would you have a conclusion now? People are, you're in between them and coffee. So I think they would like to get coffee soon.
Hello, everyone. I'm back. So I'm gonna do some closing remarks here, real quick, and then towards the end of this, I'll kind of announce the presentation winners. And thanks again, everyone, for participating. Like, the presentations were awesome. It sounds like everyone like did some really cool and creative things. So I'm gonna get started here. Oh, can someone enable screen sharing so that I can show my slides? Awesome, thank you. Okay. Folks can see my slides? Cool, awesome. Yeah, so like I said, thank you all for participating. You know, it's been really exciting to like be giving or like hosting these like hackathons with Sam and the other organizers, both at Wisconsin, at CMU, and now like here at the AutoML Fall School. I will say that this hackathon was pretty like unique with respect to the other ones, because everyone here like already had so much background knowledge in AutoML. And so the ideas that people came up with were all like extremely impressive and just above and beyond. And I think everyone working on these things at the fall school like has a very, very, very strong chance of doing well in the competition. So I very strongly encourage you to continue working on your methods. Here are the outcomes of the hackathon. Last I checked, 2 teams entered the raffle. So awesome job getting a head start on submitting your methods. And okay, I put 6 teams presented in my notes because 6 teams signed up, but I think we only saw 5 presentations. So 5 teams presented, and they were all amazing. I don't actually have slides for this, but I'll kind of announce it verbally. The winners of the presentations, well, first I'll start with the second place winner. So the second place winning team that will win a $100 Amazon gift card is the team Maybe Winning. Awesome job. So the first place team that will be winning a $200 Amazon gift card is Team 42 for their Magic Random Number 42.
Come to the front. We'd like to have a picture of you. Okay. That's part of being eligible for the prize.
Both teams?
Yeah, come on, sexy model. Come on. Smile already. That pose. Okay. And then short things together, maybe.
Or just don't look into it.
Is this okay? Good. Would you like to dance, maybe? Sorry? Would you like to dance, maybe? Perfect. Congratulations.
Oh, and quick side note, whoever took the pictures, can you send those to me? We're like adding hackathon pictures to our NeurIP slides. So yeah, if people are okay with being in the slides. Awesome.
Yeah.
Cool. Okay. So again, I've said this numerous times now. I sound like a broken record. Thank you all for participating. It's been a lot of fun. It's been really exciting, like working on this competition. It's like truly just like great to see so many people like interested in like trying things out for AutoML for diverse tasks. This is a research area that I'm personally really like invested in, and so it's cool to see other people excited about it. And with that said, here's the current leaderboard. There are a lot of there are a decent number of submissions now, and most of them are kind of like tied around like baseline level. And from these, there's a lot of area for improvement. Like you could even just submit XGBoost again and probably improve upon these. But beyond that, like the top teams aren't very far ahead of the baselines. Like there's still like a huge room for improvement here. So definitely like everyone who's been working on methods for this, like you should be encouraged by this. Like essentially, if you can get something running, it's likely going to work. Yeah, I mean, the grand prize winner of the $15,000 top prize might be like a fall school attendee. So, in fact, I think that's very likely, seeing as that everyone here is like so well prepared. Yeah, keep improving your stuff, and you're extremely likely to see good results. And I'll end with that. Thanks again, everyone.
Thanks again very much for organizing that here with us and giving so much input. And I hope I speak for all of you that was a great experience. And I think it's only a starting point. As I told some of you already yesterday, I believe that that fall school will win the competition. So I really count on you. So please simply do it, right? It's easy, as I said, right? It's only a small room for improvement. You have done it. Good, perfect. Anything else from the competition organizer? If not, then
all I've got.
Thank you again. Good. Then.
Can I speak?
Yeah, sure.
So one of our speakers, Nick, donated a wine bottle, and we would like to gift it to the first team.
Can you give it to the second team? So it's our team, give it to the second team.
Are you sure?
Yeah, we have a wine bottle.
Okay, then the second team.
Okay, and another wine bottle. So.
Yeah, give it to the second place team.
Yeah.
Okay.
Can one of you, please?
Thank you. Thank you. So, as a starting point for the winning party today, right?